Ground source heat pump is a method of using the Earth's temperatures to be used to heat and cool buildings, structures, buildings on campuses. So this is not a one-off type of technology for one building. It can be used in district energy systems, and it's really getting some legs here recently because there's now federal funding behind it. It's a sustainable solution, and it takes carbon-based fuels out of the equation, so it's very environmentally friendly. There are two types of ground source heat pumps that we deal with. One is a closed loop system, where a 1-inch diameter HDPE pipe is placed in the ground, either in vertical boreholes that go down 300 to 500 feet deep, or in slinkies that are spread across below the ground surface, but those are shallow, only about 10-ish feet deep, in trenches or beneath fields. What happens at the surface is a cold fluid is pushed down into the 1-inch diameter pipes. The below ground temperatures that we're trying to attract, it's usually around 55. That 55-degree temperature moves some of that heat energy into the cold fluid. We drive these temperatures down in the fluids down to about 32 degrees, and we try and create a delta T, a change in temperature, so that 32-degree fluid comes back to the surface at 37 degrees, and you've got a benefit of 5 degrees that you've gained. For cooling, you collect the heat in the building, run it through the heat pump, the mechanical device, and push that heat now back down into the ground, and it gets dispersed back into the ground. The open loop system is where we extract groundwater directly out of an aquifer from an extraction well. And then that process is exactly the same. That water is at a temperature of 55 degrees. So now you're dealing with a much higher temperature. That temperature is compressed and pushed out into the building to heat. Same thing happens in cooling. Collect the heat in the building, run it through the heat pump, push it back down into a reinjection or return well, and there you have the ground source system. It was easy back when ground source heat pumps were just being designed and installed for a house. Now we're talking about an entire college campus or a data center that requires tons and tons of cooling. And the Earth can handle a lot of this heating and cooling through what I just described, both of these closed and open loop ground source systems. It's best in these systems if you have alternative uses next to that factory or data center where a mechanical engineer would dump heat off to heat an office building or an apartment complex. That way you don't have to put all that heat back in the ground. That's the beautiful system.